Binary fission is a word you might come across in food safety. What this means is this is how bacteria multiply. They double. With human beings, when we reach maturity, we give birth to children. They reach maturity, they give birth to children. When bacteria reach maturity, they split in half, or they double in number. So under ideal conditions of food, moisture, warmth and time, pathogens will multiply every 10 to 20 minutes. In other words, they'll double every 10 to 20 minutes. To give an example of time, if we start off with one bacterium, give it 24 hours with plenty of food, moisture and warmth, and one bacterium will develop into 7 billion bacteria. Now to show you that graphically, if you look at the left hand side of the slide, you'll see 4 petri dishes, or they're supposed to resemble petri dishes. In the first dish at the top you've got one bacterium. Within 10 to 20 minutes that develops into 2 bacteria. That then, after 10 to 20 minutes, develops into 4, develops into 8, 16, 32, 64, 128. So they're actually doubling every 10 to 20 minutes, not going up in ones. This is called logarithmic multiplication. So they go through a logarithmic scale rather than a linear scale. Now I want to introduce you to spores, and in particular spore formation. Only 2 bacteria form spores, and they are Clostridium and Bacillus. Now we've already met a couple of different types of Clostridium and Bacillus: Clostridium perfringens, Clostridium botulinum and Bacillus cereus. There are other versions of spores within nature, not related to food safety. For example, Bacillus anthracus is the anthrax spore. Clostridium tetani is the tetanus spore. Spore formation occurs with Clostridium and Bacillus during a resistant resting phase. In other words, when conditions become too adverse, they will develop, the bacteria that is, into spores. Spores can survive high temperatures. Some spores in excess of 3000 degrees Celsius. Some spores can survive low temperatures in excess of -200 degrees Celsius. Some spores can last for millions of years and then be regerminated. There's been examples of spores found in bees' intestines, where the bees have been preserved in amber for 40 million years. They can also survive chemicals such as disinfectants, and they can survive dehydration. So let's have a look at that graphically. Where Clostridium and Bacillus have been subjected to adverse conditions such as too much heat, dehydration, or they've been subjected to disinfectants, they will form a spore within the cell itself. The rest of the cell disintegrates, thus releasing the spore. Think of a spore as a dried, ungerminated seed. A spore will last indefinitely in dry conditions until it's germinated. The only way that germination can take place is in warm conditions with the addition of moisture. And when the spore then germinates, the cell that comes from the germination will need to have nutrients such as protein in order to grow. For all intents and purposes, spores are harmless. We ingest spores on a daily basis in our food and our drink. They go straight through our body and end up in feces. They won't germinate in the adult body because of the acidic environment. But one such exception would be with very young children under 12 months. There is a condition known as infant botulism, where if a very young child under 12 months, for example, ingests Clostridium botulinum spores, the spores will germinate because the environment inside a young child is not that acidic. So the spores will germinate into a bacteria. The bacteria will multiply, and as they multiply they give off a neurotoxin, and that's deadly poisonous. And you will find, or could find, Clostridium botulinum spores in jars of honey, and you will find that on the label, warning you not to feed honey to children under 12 months. So if you look at the graphic in front of you, given suitable conditions such as moisture and warmth within a temperature danger zone, a spore will germinate into another bacterium. And since that spore has now germinated, that one bacterium will now start to multiply into 2, 4, 8, 16, etc. with suitable conditions. The canning industry is actually based upon killing Clostridium botulinum spores, and the botulinum cook, as we call it, is 121 degrees Celsius for 3 minutes or more, depending on the size of the container, the can, or the amount of food that's in the container. There have been examples of Clostridium botulinum poisoning over the years. There was one in the United States quite a few years ago where at least 350 people died from Clostridium botulinum poisoning or botulism. And as I've already mentioned, it's when bacteria multiply in food that it gives off, it exudes a poison called a neurotoxin, which blocks all messages from the brain to the rest of the body and basically it shuts you down from the inside. So it's quite a nasty way to go. The thing with Clostridium botulinum spores and bacteria, they like to multiply in a vacuum. So you can imagine in a tin, in a can, or in bottling processes, for example, they've got the ideal conditions in which to multiply, as not all bacteria need oxygen in order to multiply. Now, I've briefly mentioned toxins in the last couple of slides, so let's have a look at toxins in more detail. Toxins then are poisons produced by some bacteria, not all bacteria, and there are two types of toxins. There are exotoxins. These are produced when bacteria grow in food, for example Staphylococcus aureus. So if we cough or sneeze over food, the bacteria will start to multiply, and as they multiply, they give off a waste material. Much like us as humans give off feces and urine as waste material, the toxins are the waste material of the bacteria, and these are poisonous to us. And the other type of toxin is an endotoxin, and these are toxins released by bacteria on death in the intestine, for example salmonella, or when spores are formed, because in effect when spores are formed the rest of the bacteria dies. Again, the waste material, the decompositive material that's coming from the bacteria as they're dying, is poisonous to us.